So if we look at a couple of these examples right here, x or z squared minus 16, we see the base z squared minus the base 4 squared. It fits our pattern. It's the difference of two perfect squares, so it's going to factor into the sum and difference of those terms. So z plus 4, z minus 4, and that is your factored form. Okay. All right, when you see difference of squares, or first of all, when you see just two terms and you're being asked to factor, it's either going to be remove common factors or sum or difference of squares or sum or difference of cubes. Okay, so here I'm just going to move across the top. So when I look at this next problem, 49r squared is the base 7r squared, and 81 is the base 9 squared. If you recognize that, whether you physically write it out or just mentally recognize that, then you know you're dealing with the sum and difference of these terms, so 7r and 9. And so the factored form here would be the sum and difference of those terms. Okay, when you look at this next example, here 3p squared is not a perfect square, but you can follow the first rule, which is remove common factors. So if I take out a 3 from each of these first, I'm left with a p squared and a plus 36. Now I have two perfect squares, but it's the sum of two squares, so it doesn't fit this pattern. It's irreducible. There's nothing else I can do to it other than remove the common factors. Okay, that brings us to this next problem, where you have, again, the difference of two squares. So we have the base 6 squared minus the base p squared. When you look at those, it does fit our pattern. So we could write the sum and difference of the same terms, 6 and p. So sum of terms, difference of terms. And now, one of the things that you are going to be asked to do is get in the habit of writing your all factors in standard form. So highest degree to lowest. So the constants are going to go last. So this is a p plus 6, and this is a negative p plus 6. And then also to write any non-monomial factors with a leading coefficient that's positive. So here our leading coefficient is a negative, so I want to factor that out. So I pulled this negative out in front. I left my p plus 6. It's going to change the sign of both these terms, a positive p and a minus 6. And so this would be the simplified form I'd be looking for. Now, the computer will likely accept this as the correct answer. It will read any of these as being correct answers. But what's going to happen later when we get into rational forms and fractions where you're canceling factors is you need to be able to put everything in the same form. And so in order to see if p minus 6 cancels, it needs to be written in this form. Okay, now, the other way that you could have approached that would have been to do the same thing at the very beginning of this problem. So if I reordered my terms and made the leading coefficient positive, so this would become a negative p squared and a minus 36, I could then see that this is p plus 6, p minus 6, and I can get my answer that way as well. Okay. When you're being asked to factor an expression, it wants you to write it in the most fully factored form that you possibly can. Okay. So if you look at a problem like this one right here, and you notice that both of these terms are perfect squares. So if you think of this as, well, this is the quantity 10 squared minus 12p squared, what you might see is this factors into the sum and difference of 10 and 12p, sum and difference. But if you leave it like this, if you enter your answer here, it's going to be marked wrong. And the reason is each of these individual terms now still have common factors. Between 10 and 12, you can remove a common factor of 2, leaving 5 plus 6p. And in this, you can remove a common factor of 2 as well, leaving 5 minus 6p. 2 times 2 is 4. Now, as I write these, I'm going to reorder my terms in the factor so they are in standard form, so 6p plus 5. And then here I get negative 6p plus 5. And I want all my non-monomial factors to have leading coefficients that are positive, so I'm going to remove that factor of negative. My 6p minus or plus 5 stays, but then this changed the sign of each term, positive 6p and a minus 5. And so eventually, this is my solution. Now, to save on that, the idea is the first step anytime you're looking to factor is remove common factors. So that's actually what should have been done first. Even though you recognize these are perfect squares, look to see, are there any common factors? Okay, so each of these have a common factor of 4. So if you take out, if you reorder these and take out the 4, so a negative 4, that's going to leave a minus 25 for my constant. And my second degree term, negative 4 goes in here, 36. So I get 36p squared minus 25. And now from here, I can directly solve. It's the difference of two perfect squares, 6p and 5. So it factors into the sum and difference of those. And so if you were to recognize that at the beginning, it'll save you a little bit of time. And again, many students forget and don't see it in this step.